Merħba, niltaqgħu għal programm ieħor L-Intrapriża. Illum se nżuru kumpanija Ġermaniża li twaqfet f'Malta fis-sena 1991 u li llum timpjega l fuq minn 400 ruħ, Seifert Systems Limited. Il-kumpanija tispeċjalizza f'soluzzjonijiet għall-immaniġjar ta' sħana li toħroġ minn tagħmir varju, barra li tagħmel prodotti oħrajn. Il-kumpanija għaddejja minn fażi ta' tkabbir u modernizzar tal-makkinarju tagħha. Apparti milli tkabbar il-kapaċità produttiva tagħha, hija wkoll konxja mill-impenn sabiex tkun kumpanija aktar sostenibbli u effiċjenti fit-tnaqqis tal-emissjonijiet tal-karbonju. Dan il-proġett ta' trasformazzjoni irrikjeda studji tal-proċessi tal-produzzjoni biex ikun hemm aktar effiċjenza li twassal għal makkinarju u fabbrika li llum isejħula Smart Factory. Segwi dana fiż-żjara tagħna l-Operations Manager Philip Seifert li jiġi t-tielet ġenerazzjoni fit-tmexxija tal-kumpanija Seifert. So Philip, how did your company start and what does it actually do?
So we were originally founded by my grandfather in Germany in 1965, actually working out of his mother's kitchen, which, as you can imagine, didn't last very long. He set up the business over the years then, and my father came here in 1995 to set up Malta as a location for us for a year and never left. Over the years then it grew into what you see around you today with all the people we have here and all the investment as
And now you are third generation in the company, no?
Exactly. My father is the CEO of the group today, and I'm responsible for Malta as a production location.
Okay, and what do you actually do? What are your products?
So we produce climate control solutions for industry. So as we know, digitization is a big topic today. With digitization come electronics that have to be cooled, and that's what we provide.
Okay, and so it will be very interesting to see now the processes. I mentioned that you have now a smart factory, but it started off from the old part. So it would be very interesting to see the old part and going into the new part now. Shall we go and see that?
Let's do it.
Good.
What you see here is the old way of doing things. Essentially, we're cutting bits of sheet metal out of a large sheet. And while the punching process itself remains the same in the new building, as you can see, all raw material needs to be loaded on manually. The finished parts have to be removed manually. It's very reliant on the operator to set up the machine while the machine is stopped. So you have a lot of inefficiencies that come out of a lack of automation and a lack of then digitization when it comes to the handling.
As well, probably,
exactly.
Yes?
I mean, as you can see and can hear right now, the machine stopped. So it's not productive, it's still costing us money. It's just not the more modern way of conducting the exact same process. And it means that we're very reliant on fairly skilled people, which today is difficult to find. And even as we go into then the following processes, it still remains completely manual. So we're taking the flat parts that come off the machine. They're taken with a palletizer. We have to move them down to the following machinery, bring them up to our workspace, and then start to bend through. So there's a lot of manual intervention until we get to this point where we can actually start to do the work required again. And the inefficiency that results from that is what really pushed us to go into this new investment now. So this is now our new smart factory. We started building over here in November of 21. And are currently still in the last little stages of getting all the machinery tied in together. We essentially built the building around the machinery and the system that runs it. On our right over here, we have the raw material being taken off of the pallets and being prepared to be brought into the storage system itself. That's then placed onto the material carriers, and from there it runs automatically
the system
within
takes care
the
of
system.
every process
Exactly.
then.
So we have to tell the system once what we are loading, since we work with a number of different materials.
Yeah.
And then the software that runs the system, that's connected to our ERP system, to our quality systems, tells the machines what they need to be doing and provides them with the correct material to do so. So everything you see in there is either raw material, what then goes onto the machinery, or we can actually take the cut parts and store them again so that we can better optimize the process over here.
Okay, so those trays are the actual storage of the material that needs to either to be cut or used later on in some different process, yeah?
On each of the pallets that you see, we can hold up to 3 tons of material. So in total in there, we have 530 possible spaces. That's almost 1,600 tons
Nice.
of steel. I mean, for us, that's
Quite a
massive
massive need.
Yeah. And then the innovation, the automation doesn't stop there. The process of the punching, of the cutting, is the same as what we had before, but it's the entire periphery that we took to the next level. So the material is provided automatically, the tools are brought in by the machine automatically based on the program, and the finished parts are largely then removed and returned to stock automatically.
So in this process, you have removed the muscle power of the person and using the person as a monitoring and quality control, right?
Exactly,
That's
it's really the emphasis on the brain power then. The depth of knowledge needed to make this work in an integrated way is much, much higher. So on one hand, that for us meant elevated needs for our personnel, but it also meant career opportunities and advancements for the people who before just ran the machines. And we have a duplication over here. So on this machine, we have purely the punching process. So like you would see over here, we're simply putting the different shapes into the flat part. Maybe we're adding a small forming.
Yeah.
Whereas on the other machine, we have the same punching, but we also have the option to laser cut.
Okay.
So where you have maybe an unusual shape, or where you want to go really fast or do a prototype, you do a laser cut instead of just a mechanical punching.
Okay.
Exactly. And you can actually see that running now, where those brass brushes are coming down.
Okay.
That is actually the laser cutting process running. So as you can see, the scale of the system is really quite massive. The building itself is 40 by 32 meters, and because of the dynamic loads that we're working with here, there's actually no expansion joints at all in the floor.
On the floor.
Exactly.
So it's a specially made flooring.
Exactly. We had to get in specialists from Italy who have experience with this. There's only expansion joints at the sides because the entire floor is floating upon its own platform to make sure that when we move the material, which is 16 tons potentially that's moving, that there's no issues with misalignment or anything like that. Yeah. And I mean, not only the floor, but the entire building was really conceived for this, and at what for us is the highest level. So you might notice none of the windows have direct sunlight hitting them to avoid heat building up in here. All of the panels are all in sandwich construction, so we have insulation on the inside to prevent excess heat.
Heat coming in.
Exactly, or it getting too cold in winter. We have the big fans up top, which are integrated in a system to provide optimal airflow and air exchange, and hence why we use the height as well to get all the warm air which rises out and to suck in cool air from the adjacent buildings, to try and provide as good of a working environment as possible without having then to add on costs with air conditioning, for example. And as with the entire rest of the facility, it's completely blanketed in solar panels. So here we have an additional 300 solar panels, 420
On top of
watts
this
each.
roof.
Exactly, which effectively makes the building energy self-sufficient.
Okay.
We still put it into our use and have to take some, but net, we generate more electricity here than we actually consume. So here I want to show you one of our applications in its final place. And one of the ones I think we're particularly proud of as well, because it shows what we as a company do in or where we live within our niche.
And you're actually customizing it to a specific need, eh?
Exactly.
Okay.
You have a bending machine, one of the ones that we bought over here, and we're a supplier to this particular machine manufacturer. Within here, you have all of the control electronics that control the machine.
Okay.
And like with any computer at home, these get warm, so we cool them. So
That
this all
creates heat.
exactly. Everything in here is what controls what the machine does, and as you notice when we open it, it creates a fair amount of heat. In the door over here is our AC. You notice from the outside you don't see anything except the inlet and outlet, and what we actually did is we took a standard AC and cut the cooling circuit in half. Because of these big drives, we needed space in here, so we just cut it in half, extended it, and now it fits inside perfectly without ever noticing from the outside. This was specially developed just for this customer, but that is exactly what we do, and we do well. If a customer needs something specific, something adapted, they come to us. So you have the heat coming in at the top.
Okay.
Since hot air rises, we pull in at the top. And at the bottom, it blows out cold then.
Yeah.
At the same time, from the outside, you have the same thing. You have it sucking in from the bottom and blowing out at the top. So it sucks in the cold air, it transfers the heat, and then it blows out the hot air again at the top. The concept is exactly like your fridge at home.
Okay.
But what we're cooling is a little more electronic than what might be in your fridge, and a little more specialized than what you might have in your fridge. Here we're in our production lines now, on one of our production lines. You might recognize the cabinet from what we saw earlier.
Before the bending.
Exactly. But here we're now assembling the finished product. So we take items that we produce in-house, like our condensers here. We start to prepare what we call our middle. So that is really the heart of the cooling circuit. Your hot side on one side, your cold side on the other. And then together with all the cabling and electrical preparation, gets prepared to then be moved into the cabinet itself. We start to bring together then the different components. You might have, like here, a touchpad that's adhered on the side, or we might have certain things that are riveted in place, and then we start to add major components. So as we go through here, you have air movers being put in place to actually circulate the air that's flowing through the product, and step by step, you build up then to a complete refrigeration circuit. We have the compressor, which is what moves the refrigerant around the circuit. Yeah, that's all being prepared over here until we get to the end then, where we pull a vacuum first to make sure there's no air inside. And then we have a refrigerant filling machine, which actually puts refrigerant into it. And that is actually what circulates inside and what allows us to do the cooling. We have a visual check that goes across, so the person working here is typically someone with a lot of experience who knows what to look out for the typical easy mistakes, gives it all a once over, and then passes it on to testing. Every single
testing stage is in there, right?
Exactly. The testing stage is in there. We connect everything up to a test box, which we build ourselves, which we completely develop in-house. The test box programs the unit, so it tells it in 35 degrees Celsius, run at this power, turn this on, turn that function off. and then it runs through a full functional test. So it cycles itself on, it starts cooling, it blows air in and out, it goes through all the different test parameters that would be needed then in the actual real running, and then automatically gives the operator feedback on pass or fail. So it's not something we leave up to an individual to decide. The system tests everything and then passes on that information, either for follow-up if there's a problem, or it issues then a test sticker which goes out of the building then with the unit. And when you look at our different production lines, the concept is always the same. You always have a compressor, a warm side and a cold side, and refrigerant running across it in order to perform the cooling. What changes is the form factor. So some customers have certain space limitations, some customers...
It needs to be modified.
Exactly. Some customers maybe want to mount this on the roof instead of on the wall of their cabinet, or maybe they just want a different color. And that is all what we can do for them. Whatever the adaptation is, that's where we specialize. From here then, these are packaged and shipped out all over the world. What we see here is our Kanban shelf now. When you think about a shelf, I mean, usually a shelf is a shelf. There's nothing really special about it, but there's something quite special about this. You see, these are all of our C parts. So screws, nuts, washers, things that you use commonly in all products. And instead of kitting these from our warehouse where you have to count screw by screw,
Yes.
these are kept here for all of the production lines. And anyone who needs something can go up, they can take what they need, and then the genius bit comes. So these boxes have an RFID chip inside them, which connects to electronics, which are only in the top shelves. So the idea is when this is empty, I take this box,
And
I put it on top, and then the shelf knows, that box is empty. And with the connector hanging on the wall, it sends an order to the main depot in Germany for replenishment.
To supply you with the
Exactly.
with the needs.
And twice a week, someone shows up at our facility to refill them, and we get a bill once a month. It's so fantastic because we can just go up, we get what we need, we never need to worry about reordering or not having enough.
Yeah.
We just find what we need immediately.
L-inċentivi li nistgħu noffru biex ngħinu kumpaniji jagħmlu investimenti li jimmodernizzaw il-proċessi, jupgradeaw l-equipment tagħhom, jixtru makkinarju iktar effiċjenti, huwa primarjament dak li jingħad taħt l-Invest Scheme. Permezz ta' din l-iskema, kumpanija skont l-ammonti tinvesti u skont il-parametri li tħallina nagħmlu l-Unjoni Ewropea jistgħu jieħdu kreditu ta' taxxa li mbagħad jinqata mit-taxxa dovuta mill-kumpaniji. Ħaġa oħra li nistgħu ngħinu fuqha hija l-Investment Aid for Energy Efficiency Projects. Dan it-tip ta' inċentiv jaħdem biex ngħinu kumpaniji jibdlu makkinarju u equipment antikwat li biktar makkinarju modern u effiċjenti biex allura jiżguraw is-sostenibilità tagħhom f'Malta.
Wasanna fit-tmiem ta' din il-mawra, imma qabel nagħlqu l-programm nagħtu ħarsa bħas-soltu lejn il-kalendarju. Saħħa u sliem.